Okay, so we will resume proceedings. I'll just take a little bit of time from the break, but hopefully you managed a little bit of downtime, cup of tea, slice of turkey, whatever the case may be. So we're moving into the second half of the symposium, and it's a real pleasure to introduce Dr. Naomi Hennah from Bedford College Group, UK. And Naomi, uh, as anybody who knows her work, has a lot of interest in RSC language learning within the context of chemistry education. She is a long-time school teacher, and for the past decade or so was teacher researcher at Northampton School for Boys. During that time, did a lot of, well, I think innovative practice is too reductive, but a lot of very exciting um, thinking and researching around learning in school environments. And part of that work was the reason she won the 2018 Royal Society of Chemistry Schools Education Award, very prestigious award for the RSC. Since 2024, she has joined the Bedford College Group as a learning excellence coach. And in 2024, she was awarded a PhD by publication on the basis of her very extensive publication profile in this domain. So, Naomi, thank you very much for joining us, and I'm very excited to hear your talk. I will stop sharing my screen now, and then you should be able to share yours.
And, oh no, that's my Word document. And here we go. Is that right?
Perfect. Yeah, you can just click hide. Yeah, thank you.
Okay, hello everybody. So I'm going to give you a different perspective on language, which has grown out of my experience of teaching chemistry. So I conducted practice-orientated research, and in the process of sort of garnering a deeper understanding of language and chemistry, it came as a growing perception that science doesn't expose nature, it describes it. And understanding this is critical, because suddenly you realize that chemical concepts are not tangible, but they are created by language and they exist as semiotic constructs. For my work in school, I adopted a sociocultural linguistic approach, which understands that an individual's intellectual development results from social activity mediated by language. Okay, so for this work that I'm going to describe today, I'm going to go through the process of kind of trying to understand what is being said in the laboratory and what insights being able to understand what the students are saying could lead us to. So to do this, before I go any further, I just want to clarify a couple of terms that I'm going to use. My understanding of discourse is verbal interchange of ideas on a subject, and by multimodality, I'm referring to communication or meaning-making modes such as writing, an image, three-dimensional models, gesture, and gaze. And finally, because it's all about practical work, I'm describing practical work as hands-on laboratory activities. Okay, and a lot of this work is based from an understanding garnered from Abrahams and Miller, particularly their work in 2008. Okay, so essentially in science education as a whole, as well as chemistry education as a part, we have a great faith in the importance of practical work as a tool for learning. However, the evidence to support this is disputed. So what the students are actually thinking about what they're doing while they're doing it needs to be understood to try and develop learning in the situation. Lemke said that it's a language problem. his famous work, Talking Science, basically relates science to language. Science is language. Okay, so let's begin with practical work. Practical work, at its most simple, can be conceived as linking the things that we can see and touch with the underlying concepts. Abrahams and Miller produced a rubric for trying to understand how effective a particular practical task was. And they looked at what was happening in what the students were doing and what they were learning. Okay, so this rubric formed the basis of how I understand dissecting practical work to make judgments on how effective it is being. Okay, so the problem with understanding what's being learnt is you need to know what the students are thinking, and it's very difficult to get access to thought. Vygotsky very simply expresses, though, that words are a direct pathway to thought, and indeed thoughts come into existence when thinking. So let's just think about chemistry specifically for a moment. Those of you that are familiar with this is Johnson's triangle, which is a mechanism of understanding that when teaching and learning chemistry, this occurs on 3 different levels of thought. You could be thinking about the macroscopic, what we can see and touch, the submicroscopic, which is the particles themselves, and indeed the representational, which is your symbols and equations. Now, what does that actually mean for somebody that is looking at language research in the laboratory? Well, let's take the word water. Water might be the liquid that's in front of you. It could be the particles, or indeed water could be referring to the written symbols H2O. Okay, so to understand the language being used in the chemistry laboratory, you need to contextualize it. And to contextualize it means that you have to access different modes. So we're going to look at how to explore effectiveness of practical work and looking at language, and then we need a framework to understand what sort of language occurs. And I found this model, which expresses the idea that language learning opportunities occur in 3 distinct areas. And so I've divided my practical lessons into 3 distinct areas. Pre-experimental phase, where I look for what language is introduced by the teacher. The experimental phase, what language are the students actually using? And the post-experimental phase, which is where the students and the teachers come together and discuss what the practical work has demonstrated. They might reiterate the language used, they might analyze the results, produce graphs, etc. But it's perhaps the most important phase of the experiment. So let's take a look at the sort of results that I obtained and produced. So I watched and recorded with multiple cameras these students in their lesson, and just to show how the 3-part lesson can be viewed. This particular example of a multimodal transcription is taken from the very first part of a lesson where the teacher is introducing and demonstrating the practical work. And you can see here that they are modeling the language, red litmus, and also the scientific process, writing down the observations. We've got a table of results that's being filled in. Okay, so I put these ideas together. So we've got the Abrahams and Miller's table working on the two levels. So on the left-hand side there, you can see domain of observables, the kind of procedural activities, domain of ideas, which is the conceptual ideas. You can see the key words contextualized pertaining to the macroscopic, submicroscopic, or symbolic areas. And then you can, last but not least, see where I have divided the lesson into the 3 phases. And literally what I did was I took a word list, a keyword list for the topic that was being studied. And I also watched and listened to the recordings of the teacher talking. And I identified a number of terms that were being used. And if we take the word acid, for example, there, you can see the word acid occurs both in the macroscopic. So if we were to look at a solution of hydrochloric acid, and it also occurs in the submicroscopic, where acid we're referring to hydrogen ions, or the acidic nature of the solution. And literally I tracked through and counted the frequency of the words used by the teacher at each part of the practical task and the words used by the students. Naturally, the number of times the words used by the student should be larger than that of the teacher because there's more of them. So this gave me an understanding of what words were being used and when they were being used. Why was that interesting? Well, it had some very clear implications for what we were doing. So I might add that I looked at more than one experiment, and so I could compare an experiment that had a clear table of results with one that didn't. And I noticed that the table of results was actually providing a structure for what communication was taking place. So for the same experiment, on the top there, I've got one table of results, and then I've got, based on my results, a second table. And you can see that I've added in a prediction column because I want to get the students talking about what they think is going to happen. There is also an interpretation of results because I want them to think about what the results mean. And to make sure that that's what they're thinking about, I create a situation where that's what they're saying. Prediction leads to a linguistic relationship between the name of the solution and the prediction that they're making. So here, any solution that has the word acid in its name, you would expect it to turn blue litmus paper red. Okay, so that was one outcome. Second outcome that came from doing this work was that as a department in the school, it really emphasized the relationship between language and students' understanding. And it emphasized, for example, that a diagram like the one shown here labels pH 1 as strong acid, whereas that can lead to a misunderstanding or miscomprehension of the difference between pH as a measure of concentration of hydrogen ions in solution and strength of acid, which means how readily it dissociates. But there was another finding that came to light by studying the teacher's actual spoken language. And I think this this links in nicely with what we've heard before about language choices. So on the far right there, you can see hydrogen ions and hydroxide ions drawn on the board. Now, there's a whole discussion that we could have about the colours chosen, but let's just think that the teacher is talking about hydrogen ions and hydroxide ions. But yet, you can see here in the verbal communication that for the hydroxide ions, he's referring to the OHs, not OH minus ions, but OHs. So that's like he's using symbolic language incorrectly as a sort of a shortcut rather than saying hydroxide ions. And indeed, the same's happening with the hydrogen ions. So for the chemists amongst us, you'll realize the implication of that. And when I drew his attention to it, he was quite horrified that that's in fact what had happened. Okay, so that was the first part of the research that I was conducting. And then the second thing was that I have this firm belief in oracy, spoken language, and how it is a tool to develop learning, and it affords us not only the opportunity to understand what the students are saying, but also gives us access to how we could possibly improve our work so that we create opportunities for them to use the language that we want them to use. Literature research brought me to this fantastic work that's published in the field of physics, which looks at torque moves, which are those verbal actions that transform a string of parallel utterances into a conversation. And here we can see work that was done to link the talk to particular levels, so a linguistic level, so that would be Abraham's and Miller's level in the domain of observables, and the cognitive level corresponds with the domain of ideas. So in fact, what I did was I married up the two models, and here we've got ultimately the rubric that I used to understand, to analyze the talk that was happening in the classroom to see if I could identify particular chains of conversation and deduce how that played out against the actions that were taking place. And remember, it's multimodal, so I could always contextualize it by watching the video, seeing what they were doing. So if we take the purpose moves down here, now this is, if you like, the point of practical work that is most disputed. The fact that students are not necessarily learning about the underlying concepts. Okay, so what we intend them to learn isn't what's being learned. And in all the transcripts that I produced from these students, I in fact found an example of what I was hoping to see. Here we can see an exchange between three students. One student's arrived late, so has missed the teacher's introduction. And what we can see is two wonderful things happening. We can see here that the late student, student 3, S3, nothing happened. It's the same. And his partner qualifies this by actually reforming his statement in the language modeled by the teacher. No change. It is not an alkali. Okay. And then further on, we have this moment of creating new knowledge. The student's taking on board his partner's saying, it's not an acid, so it has to be neutral. And the student realizes if that there is not a positive test for either the red litmus paper or the blue litmus paper, you can conclude that the solution being tested is neutral. And then he thinks about it. What he said is qualified by one of his lab partners, and then goes, okay, it's water. That makes sense, because we teach students that water is a neutral solution. I know that's broad stroke statement, but at this stage for 11-year-olds, water is a neutral solution. Okay, so why am I excited about this? This works. So we saw with the first method that, sorry, the first rubric that I produced, that we had a way of understanding language being used within the classroom by tracking word usage. And if we make changes to the table of results, we can create opportunities for students to use particular terms or target terms more frequently. But this second rubric, just flashback here, I think offers real potential. So if people leading practical lessons become familiar with particular talk moves, they can start to hear what's happening in the exchanges between the students. So in the way we will watch what they do, we can listen to what they say and start to draw conclusions. Now, this could be formalized into a research rubric, or just give teachers ideas for what to listen for and start to interrogate changes that they can make to their practical task to encourage particular talk moves, and therefore create an environment in which the practical task effectiveness in terms of developing thinking and learning is increased. And what I'm going to do, because I am aware that time is of the essence, is I'm just going to say that on my slides there's a list of both the materials that I've used and shared with you, and also I'm directing you to a couple of really good articles, I think, in and around this area. And very much to finish with, I just want to say thank you to the Bedford College Group for giving me the opportunity to come and join in with this. Thank you very much to the RSC, particularly the Education Research Group, for giving me the opportunity to share this. And of course, to the University of Bristol Centre for Academic Language and Development for having Michael Seary, who facilitates these phenomenal opportunities. So thank you very much, everyone. And I'm going to stop if anyone has questions.
Thank you, Naomi, very much for sharing that work. And obviously, as someone who knows your work, I know you've taken a slice out of that. So I really appreciate the work you've done and just taking a common thread from across a variety of things you've been thinking about. So I will offer it out to chat for questions. I guess one thing coming up is around what was interesting is these set of explicit steps. So if we think in your purposive moves, I can say that correctly. I really love this layering of this step around linking knowledge separate to the step around building on each other's ideas, which feels very nuanced. And I'm just wondering, in listening out for that, could you just elaborate on the distinction there?
So building on ideas is very much responding to what was said before and extending it, maybe clarifying the point. So you're really developing it. It might, in fact, be that it's a challenge an aspect of what's being said and developing why you're stating that challenge. So the talk moves are about creating, are about really collaboration, coordinated verbal interaction, rather than parallel speech. In 90% of the material I analysed, students were stating their own point. They weren't listening to, they weren't, or if they were listening to, it was a yes, no kind of response. They were very much acting as individuals in terms of their thoughts, even when they were collaborating in their actions. So it's about trying to get them to think together, because drawing on Vygotsky's work, that if we build, we construct understanding, and it's that we take forward and it develops into our learning.
Yeah. Okay. Michael's commented that this sense of teaching logical writing using the claim, support, warrant approach is another way of framing moves and probably more simply.
Absolutely.
And I know you love different frameworks, so you've found and described your own. But I guess there's a couple of messages in there also about just the reality of a teaching context, certainly at school education, but I think at all levels. Like for a teacher, like in working with teachers or working with people or even working with students, how explicit do we make these structural moves in a way that might help students think about their own approaches, or teachers, like how does this actually manifest in terms of not in a research context, but in a practical
In
context?
a practical context, so very, we break it down, like absolutely everything, you break it down. So what we're talking about is we're talking about the development of an alternative classroom environment or a different culture. So we have to train the students, and those of you familiar with my work will be used to the idea that we give people specific roles. They have to be the person that asks the questions, the person that responds to the questions. So if you like, we're orchestrating dialogue. In science, we very much orchestrate activity, but not the dialogue. And so this is about that, is about thinking about what you want to say. What does it look like? What does good talk in the lesson look like? And providing frameworks. But this has to start very fundamentally and build up. So I think, for example, with the argument model, one of the reasons that the research, although theoretically is very, very strong, that the actual outcomes are not where they're hoped, it's purely because rehearsal needs to occur. It needs to become the expected way of talking. Just like students need to share equipment, they need to share conversation.
Yeah. And Keith noted there, I think, a very similar point around learners needing specific inputs to teach them to work in constructing dialogue, referencing Mercer. So I think
Yeah. So Mercer, Neil Mercer, or actually the RSC Cambridge website, full stop, is just a font of knowledge. Neil Mercer himself, absolutely brilliant. And the clarity with which he breaks down language into accessible functions for somebody like me who isn't a linguist.
Lovely, Naomi. Thank you so much for sharing that. I'm going to stop the recording, but will you please join me in thanking Naomi for her presentation?